So I'll proceed. Like I said in our last class, we normally have a cycle where we of what we do each time in data analysis. Okay, the data analysis cycle or data analysis process, which I talked about, it starts from what um getting the question. Okay, when we get the question, then or the objective, we now move from there to what getting the data. Okay, from getting the data, we now move to pre-processing and cleaning, where we try to remove null values, remove duplicate values, and ensure that outliers are not in our system. Okay, and then exploratory data analysis or EDA, where we now try to understand the data in depth, visualize the data to some degree, and then make informed decisions based on that. After which we can now present to us to the board of management or whoever is in charge that we're supposed to present to. Okay, then after that stage, if we move further into the realm of machine learning, we now when you're done with your EDA, instead of now presenting to the management board, your next task is to design what? To design a flow, a pipeline where you can now move the data into what? Training your model and what? Deploying your model. Okay. So we are going to look at all of this, okay, gradually. All right.
Did you give us a card assets?
I sent it to the group. Okay, so you add it here. Remember the format. We move it to where our file is. Okay, move it to where your file is. That's what you're going to learn. How to move it to where your file is. Very, very important. You know, at times it's more or less how you control a PC than what you are as a developer or anything. That's one thing I've learned so far in my experience. I can teach you how to code, but if you don't really know how to use your PC comfortably, it's an issue. Create a folder, put your notebook and your data in the same folder. Okay, and ensure that they are in the same place. It makes it easy for you to do what? Just write the name like this, and it will work and it come out. If you want to be using /, that means you have to create multiple folders in different places. Okay, but this is the easiest way I would recommend for beginners. Create a folder, put your data set inside of it, put your notebook inside of it, the same folder, the same level, so that once you just write the name like this, it will come out. Okay? So the first thing we're going to do is to, well, normally I'm supposed to, since this is normal class work, normal explanation, I'm just saying loading libraries and data. Okay, that is the first thing I normally do. So the first thing we do is to load the important libraries. And for the sake of our class, we are loading pandas only for now. So I'll proceed to what? To load pandas or import pandas. Okay. Once pandas is imported, the next thing I'm going to do is to do what? Import my data. Okay, my data is the line 2. Okay. I don't know why my system is taking time to import pandas. But automatically after importing pandas, you should do what? Press Shift Enter to import to load in what? Your data. Okay. By default, we normally use DF or data frame or data, basically any word. But the point is, this is just like a normal variable we did before. The DF is just a normal variable. The PD is an alias or alias, okay, for pandas. So whenever you're seeing PD, it's equivalent to writing pandas dots. Okay? Whenever you're seeing PD, it's equivalent to writing what? Pandas dots. Then the dot read CSV is just a function that we discussed in the last class. Okay? Just a function to get these things in here. Okay? So that is that. Alright? So now we are seeing some new things. And these new things came about based on questions that was asked in the class. Okay? There are some things I was trying to do, and over and over again, it became an issue that we need to set some parameters. Okay? But before we get to these ones, let's display our data sets. Okay? So I will read it, then I will display it. Now, if I just write this like this, and I have plenty data, in our case I have 300, right? Or 301. And you are seeing some dot. This is to show that this is the first 5 and the last 5, and it continues under. Okay, we have many other data sets that are not displayed. That is what this does by default. So whenever you do this, it's not going to display everything. It's just going to display the first 5 and the last 5. DF is what I called my own. Okay, so whatever you call your own is what you're going to do. Okay, so that is what DF is. So DF is now housing or holding the value that is inside this file. All the value inside that file is now inside of this DF. Okay, all the values inside the file is in the DF. Okay. Then the next thing we are going to do is, okay, before I execute this, okay, the whole point of this is to ensure that we have more rows displayed to us. Loading it. Okay. So please go ahead and type this one for those of us that are done with that level. Type this part. What you're going to learn first, I think, for simplicity, let me just do this thing for all of us. It's very, very hard. Okay, so just look at this. If I am here, okay, this is where I normally used to come. If I open this thing, this is where it normally used to stay. If I do anything here, if I stay here and click on new, okay, it will open the file somewhere I don't know. Okay, so what I normally used to advise people to do is to go to where you want to work. This is folder structure. It's just the same thing as your file explorer or your finder. Okay, so anywhere you want to stay and work with, move inside of there. If it's desktop, if you want to create a new file, just know in your mind that whatever this file is going to be is where I need to move to. So there, desktop. Now for me, I have multiple files, so I'm not in my desktop level. Everything in my desktop is showing here. Okay, everything in application in my desktop is showing here. If I should do this now, okay, you see that apart from the applications, every other folder, like I have a 1, 2, 3, 4 folders and some files. They are all showing here apart from the applications itself. 4 folders and files. 1, 2, 3, 4, and then some files, right? So everything that needs to be there will be displayed here. So that is the idea. Now you're seeing this part / desktop. Okay, so that's important basically. So each time you want to create a new file, just always maintain that order. Okay, so that it's easy for you to navigate. So that you don't have to be running from different place to another place each time. Okay. Okay. Now we are all in the same place. Let's proceed. The next line of action is to extend our view. Okay. Let's say for whatever reason you don't want to just be seeing about 60 or 100 records max. You want to see more than that. That is what this pd.options.display max row is all about. So if I should run this now, okay, if I should run this, I will see what the current maximum row is. Okay, maximum row currently is what? 60. So that means I can't display an object longer than 60 here. If I have anything like 30, 40, 50, I will display everything at once. Okay, if I have something like 50, I will display it at once. But if I have something that is bigger than, if I have 61, it will show me this thing. 10, 10, or 5, 5, 5, 10. Okay, 5, 5, 10. Right? So if I have 65, it will show me 5, 5. 5 of the head, 5 of the last, or the tail, as we call it. Okay? Then, if I want to change that number of options, I want to increase it so I can see more things now. Okay? All I have to do is to set the new max row. Okay? So I'm saying pd.options, right? Display dot max row, which is basically equal to 300, which I'm saying for the max row, I want it to be 300. Maximum rows simply means all these rows entries, records, how many should we have on a single display? Okay, how many can we display once? Okay, that's what it's saying basically. Okay, so then if I execute that, and I can still go ahead and add a new row just to verify. Okay, just to verify that it has changed. Okay, I'll run this. Now is now what? 300. Okay, so Okay, so go ahead and execute. Now dot head simply allows us to see the top of the data basically. Okay, dot head allows us to do what? See the top of our data frame. Okay, so it's by default. If I don't put 150, it will show me the first five 0 to 5 or 0 to 4 rather. Okay, it will show me first 5 0 to what 4. Okay? But if I put a number, it will show me up that number. Okay, so with this I can see the first 150 records. Okay, so now because of I'm using notebook, it's kind of not going to display this thing straight. That's why it's too long. That's why it's like a scrollable item, like so. But it's going to show me a lot of what items up to 150. Okay, so 0 to 49, 149 rather. Okay, so that's basically the difference. Okay, now I can have much more feel of my data. Okay, I can now look at it. No, okay, this is what it looks like. This is what that looks like. All right. Now we are stepping into what data cleaning again. We saw it briefly, and today you're going to see it more in depth. Now we want to see if our data set has null values. Okay, if it has null values, by default it's going to show me true false kind of look. Okay, true false kind of look. So I can't really use this to do anything unless I try to probably do dot head, then put 300, then put is not fact checking it. So this is not really like the best view. So I would have to add a sum to count it. It's easier to count 0, 1, 2, 3 than to use our eyes to say, okay, this one is true, this one is false, this one is true, this one is false. So all the false here simply means we have value. Is not is asking a question. Is there no values? So true or false is the answer. Okay? If it's true, that means there is no value. If it's false, it means there is no value. No values are empty fields, places that don't have value inside of them. So all of you're seeing here is false. So that means almost everything has what? Value in them. So another easy way to do it is just to do dot is null dot what? Sum. So that sums everything, gives us a number. Okay? Gives us maybe 3, 4, 5, meaning we have about 5 null values or about 3 null values, depending on as the case may be. Okay? So then we've seen .info before, which is just giving us an overview or a general information about our data sets. Okay, we have 9 columns, as you can see. We have 301 entries. Okay, in our 9 columns, the names are what? Car name, year, selling price, present price, kilometer per second driven, or rather kilometers driven. Then 4 type, seller type, transmission, owner. Okay, then we also have what's it called? No. Remember I said not what no means. Places that don't have what? Null values. Okay, then our data type was clearly stated: object, integer, float, integer, object, integer. Okay, as the case may be. So now this is now the place you now take some time to observe the data set and the data type and the data itself. Okay, look at the data, the column names, the data type it has. Does it make sense? Okay, that is the question you should ask yourself. Is car name supposed to be an object? Remember, objects are strings. Is year supposed to be an integer? Most of the time, years should be either integer or date. Seeing that, I think the year, from what I'm seeing over here, is just what actual numbers. So at this point, integer can serve. Okay, at this point, integer can serve. Okay, but if the year or the date had something like October, November kind of 25th kind of date, then we'll have to change it from integer to what? Date time. And we saw that in our last class, how to do that in our last class. Okay, for this one, I don't think we're doing any much cleaning. Okay, so we move forward. to performing our EDA. So EDA simply stands for Exploratory Data Analysis. Okay, EDA, Exploratory Data Analysis, and the beginning part of it is basically what doing dot describe. Okay, dot describe basically tells us a brief or summary of what our data set looks like. Okay, that dot mean dot maximum dot minimum that we did in a former class for this morning. Okay, all of those things are contained inside of what they describe. Okay, all of them are contained inside of describe. So it's just giving us an insight, okay, into our data. Now I can deduce what value should be. So if I have, well, the year shouldn't actually be here. Okay, this kind of minimum, maximum kind of value shouldn't apply to this year. The average, all those kind of things. Okay, so I will remove year. Year shouldn't be here because of its state. Okay, but I can still try to convert it so that it doesn't appear there. No. So, but let's continue. So then for selling price, we saw that the minimum price something was sold was 0.1, and it got me thinking, what can we sell 0.1? And the maximum price is what? 35, which means this may not be hundreds of dollars, this may be millions. Okay, this may be 0.1 may refer to as hundreds of thousands of dollars, while 0.9 may refer to like 900,000. Okay, why 6 may refer to what, like 6 million or something. So these are things we should verify and be sure of. What level or metrics is our value on? Okay, what metrics is our value on? Okay, so the same thing applies to the present price. Kilometers driven. Okay, 500 is the minimum, and maximum is, I believe that's 500k. Okay, the same thing applies to owner. Now, owner is more or less like an ID, right? Integers, owners are mostly what kind of value? 0, 1 kind of value. That's what owners use. So 0, 1 kind of value. So owner is majorly a categorical field. Okay, so that is what I'm seeing from here. But I still have 3. Okay, so I have to figure out why I have 3 here. These are things that you're not seeing that you have to answer to or try to find out why do I have these values like so. Okay, since my maximum is 3, my minimum is 0, and everything is 0. So where is the 3 coming from? Very good question to find out. Okay, so this is another form of performing describe summary. Okay. Over here, the describe just apply to what? Only numerical values. If you noticed, it skips everything that is not numerical. It applies to the only to the numerical values. Then over here, I'm applying it to the non-numerical values, the transmission, serial type, for type, and what? Car name. So instead of getting minimum, maximum, it chose a different approach. It's giving me number of unique values. Okay, number of unique values is giving me top, which is like mode. Okay, that is the most occurring one, and it's telling me at what frequency is this thing occurring. So this is more like it's telling me for transmission, the highest is manual, and it's 261 of it. So with this alone, I have in-depth insight into what my data is talking about. Okay, with this alone, I have an in-depth insight into what my data is talking about. Okay, so at this level, you can start writing your notes, coming up with your assumptions, and then probably talking about the next thing to do. Okay, so now when it comes to data analysis, we have what we call univariate analysis. Univariate analysis basically deals with the analysis of one feature or the analysis of one column. Okay, getting the analysis of what one feature or the analysis of what one column. Okay, trying to find out details about one column. Now, in this analysis, I'm using dot unique. Okay, dot unique is responsible for what? Returning only the unique values. Only the unique values. What do I mean by unique values? Unique values are values that occurred at least once in our data set. Okay, values that occurred at least once in our data set. Now, I'm going to give an analogy, a very simple one. We have a basket of red, blue, and black balls, and we have 20 reds, 15 black blues, and 30 black balls. Okay? So, if I'm to get the unique data from this, how many will it be? If we have 20 red balls, 15 blue balls, and 30 black balls in a basket, and you're asked what are the unique balls in the basket, what will you answer me? What are the unique values in the basket if you have this number of balls? This is a red ball, blue ball, black ball. That's the question.
What are the unique values?
Yes, the unique values.
The number of the variation, like the red balls.
Exactly. Okay. Exactly. That's what I know on date. That's number of what the variations. Okay? So these appeared ones, these appeared ones, these appeared ones. Even if you have 20 of them, you only count it once. Once that particular, if I have let's say green, and green only appeared once, how many now? Is what? 4, basically. So that's the idea. That's the idea. So the unique returns these values. Okay, these values. Then we will have another one that will show us, which is n unique. Okay, unique is telling us we have 1, 2, 3, 4. Explain out the colors, explain out the balls. Why n unique? You just say 4. Okay, n unique just give us a number. We have 5, 4, 3 unique values. Unique give us the actual value, the red ball, the black ball, the blue ball, the green ball. That's the idea behind it. Okay? So for this case, we have what? 2 unique cellular type, the data and the what? Individual. Okay? Alright, so either you do it using dot notation or you do it using what? The square brackets process notation. That's about the 2 things we need to note. So this and what we did above is basically the same thing. Okay? Either you do it this way or you do it that way. Yeah, basically the same thing. Okay, so moving up to the next one, value count. Okay, so for value count, it's similar to this unique. Okay, so it gets each unique value and counts how many times it is. So value count will actually tell us red 20, blue 15, black 30, green 1. That is what value count will do. Instead of just telling us red, blue, black, green, just give us for each one how many they are. So that is what value count or value count does for us. That's the difference between the two. None that this one is clear. Okay. So proceeding, remember I said we are going to be picking all these our columns one at a time. Okay. So we are starting with what? The columns. We've done, which one did we do first? We did cellular type. So we are moving over to what? Getting the unique cars. Okay. So we are getting the unique cars. That is the cars we have in our database. What are the unique ones and how many are they? Okay. So that's what we're doing now. So this alone can answer a lot of questions for us. This alone can answer a lot of questions for us. Okay. So this is, we have a car called City, probably Corolla City or something like that, okay, or Toyota City, whatever the name is. But the point is, you have a car called City and it's 26 and it's probably the highest, okay, followed by other cars, and we have lots of what, unique cars. Okay, we have lots of them. So there's the command to get the unique cars. Okay, so if I did an n unique to tell me how many there are, but from what I'm seeing, I'm looking at over. I think this should be over. Oh, not sure. So let me actually run an n unique to be sure how many there are. Okay, so I can just do length. Okay, unique cars. So this is only going to tell me how many, there are 98 unique cars. Okay, so either I do this like this, okay, if I don't want to use any unique, okay, there are 98 unique cars, then these are the distribution of it, okay, how it went and how it's going, basically. So I believe, go ahead and write this if you haven't written it out. But basically, it's just simply creating a variable called unique cars and getting the value count for what, our column car underscore what, name, basically, as simple as that. Okay. Okay, so moving forward, I can move forward, right? Okay. So the next thing we're going to do is start plotting. Okay. So this is what our first plot will look like. Like I said, you're going to look at this critically. Basically, going to create the plot for the head for the first 10, basically. Starting from the city down to the 10th item there. Then we're going to create a bar plot. Okay, so I'm going to proceed. I believe if I write this thing out, it's just basically car underscore unique dot head bracket 10 dot plot bracket kind equals to what, bar. So the kind parameter allows us to make changes to this plot. I mean the kind of plot you're going to plot for a time. Okay, if I change the kind from bar to something like pi, it will give me a pi plot instead of what, a bar plot. So that's the difference between this and the rest of the other things I'm going to write under. Okay, so I'll proceed. Again, another chart. This time around, we are plotting a frequency table. Okay, so the frequency table is like the opposite of this one. Okay, this is basically giving us the hierarchy, the car name, how many they are, kind of scenario. While the frequency table is telling us the frequency of occurrence. Okay, so we have more, over 70 of our data, okay, within the range of what, 0 to probably 3, or let's say 0 to 2, okay, or 1 to 3, as the case may be. Okay, so that is why we have majority of these things here. Over 70 records are ranging from what, 1 to 3. So if we move up, we have a lot of 1 and a lot of 2, okay, 2, 3, then 1, 1, 1, 1, 1. So that is what this is depicting. So up to here we have like 3, 4, 5, but we have lots of 1. Okay, that is what this frequency table is showing. It's not showing us which car is the highest, but rather in our range of cars, okay, which values of cars are what, the most occurrent, right? So we have more of our cars single than what, many, and we have very few cars within the range of what, 25, 26, practically only 1 in our case. Okay, so that is that. This is just a, like I said, half of this thing that you are seeing me display now, these are methods that are written into this thing. So all you just have to do is use them the way they are. Okay, probably as you use them, you begin to find out differences between them and what you've been using before. If you want to find out more about them, there is documentation. Okay, you can look at the documentation or you can ask AI these days. Before it was go to Stack Overflow or documentation or Google. But now you can simply ask AI and it will give you what? A seamless answer. Arrange everything for you in a simple way. So that is that. So I'll proceed. Okay. So what I'm doing here is basically what I asked us to do this morning now. Unique cars dot mean dot median range. So range is the where it starts from to where it ends, kind of. Okay. So this is basically having an insight of our data. Okay. So that is that. So what this particular one is basically going to tell us is the frequency at which these yields occurred. Okay. So what I'm going to do now is I'm going to do a value count on this year, and then we're going to compare. Okay, I already did it here actually. Okay. But this time around, I'm just going to do the value count and then print the values themselves. Okay. So we have plenty year within this range, so probably that's why we had more values over here. Okay, that's that. Please just copy this thing to let me explain later. Okay. So like I was saying, the most important thing about data analysis is not just writing this code, it's understanding the business logic behind the scene. Okay. Beyond just writing this you're writing now, you have to understand why should I even write this line of code in the first place. Okay. So we're going to look at something which is called insight from data. Okay. At the end of every question here, you're supposed to give an insight. Forget that I'm only writing few insights, but in reality, writing the insight might take you more time than writing the code. The insight is the real thing. The code is what will inform the insight. Okay, the insight is the real analysis. The code is just basically you can get the code anywhere online. But the insight is what makes you the analyst. Okay? So just bear that in mind. So I'll go ahead and execute this and this. Now I'm doing value count for price and I'm still seeing 0.45. Okay, now 0.45, I am the analyst and I work for the company. So I should know what the heck 0.45 is if you're working with the company. But I'm the analyst, I don't work for the company. This is a freelance job. They just gave me this, I just got the role, and this is what I'm saying. So I should walk to the whoever contacted me, okay? I'll be like, hello sir, this price is what's the value rate? Okay? Is this what's the scale basically? Is this in hundreds of thousands or is this millions? Okay, so you want to know if this is hundreds of thousands or millions or hundreds. If it's hundreds, that means you're having 0.20 probably cents instead of having something like um 200,000. That's the thing. These are the questions you need to find out. If this
0.45 is
in hundreds or hundreds of thousands, that's the thing to find out. So once you can get that, then you can now you ask the question, like I said, you ask whoever gives you the data. Okay, these questions. In most cases, they will clarify you what this is. Okay, sometimes you see a bracket, they will say USD 1000 or USD whatever. Okay, they will tell you the particular value should be. Okay, so these are things. Again, it's not a one way. It's not something that you must know by default. You don't get that scared of knowing it by default. They should tell you. Okay? When I did some of this kind of job, they mostly tell me, okay, this is this scale, this is that scale. These are the values that should be within this place. If you don't work for the company, if you work for the company, then you should have access to those things by default. Either you go and meet your supervisor, whoever is in charge of the project, or you go and meet the sales team. We have to create the system in the first place for collecting the data. Okay, you go and meet the person, and then they will tell you what each one is. Okay.
So what is insight here?
Insight is what you derived, what you found out from the analysis you are doing. The whole goal of this analysis is to find out something on the data. That thing you found out is the insight. Okay, based on this, I discovered that this is this. Okay, I discovered that people like buying more of meat pie and what yogurt. Okay, so what we can do now is develop a business model around this insight, which can be let's move want the let's say chicken pie to go viral, not just the meat pie, chicken pie now. Let's remove some amount of money from the chicken pie and give discount to whoever buys chicken pie and what yogurt as to buying meat pie and yogurt. That can be a strategy. Okay, or if you feel like, well, let's cut chicken pie entirely and focus on what our main market. Okay? That can be the this thing, what you found out. So it's not left for the executive to be like, okay, that makes sense. They now weigh the option based on their feelings and their human impulse and what they have envisioned. That make final decision. But your own is to suggest those things to them. You tell them based on what I'm saying, this is what we should be heading to. Okay, that's the insight. Then for machine learning, eventually the insight is basically what the model tells you. Okay, so for now the model is going to tell you either good or bad, classify this as this or that. But for data analysis, the insight is coming from the person. Okay, that's just the difference. All right, we did something similar here again. Here we did the maximum minimum kind of thing, but this time around I didn't make it beautiful. I just wrote it in one single line. Then we now plotted the histogram. So from the chart above, we can see that most sales in the company is from the cars with the selling price of what? $0.2 million to what? $10 million. Okay, so that is what the chart is telling us. Most cars in the company are from what? $0.2 million to $10 million. If I went up over here, I may not necessarily get that from this. Well, at least I'm seeing 0.45 in 8, 0.6 in 8, 5.7 in 7. Okay, so this is telling me that for at least from 0.4 to 5 point something has high values, right? I'm also seeing 0.26, okay, 0.45. So anything below that, anything below 0.2 here, can't seem to find anything below 0.2 sharp. But I know that they should be. Okay, but this is quite okay. I saw one. Saw one. So this is almost like unreadable like this. Because it's not that clear, it's not that arranged. I can sort it though and make it more readable, but the chart can also save us that stress when we plot a chart. Okay? It saves us that stress. Then from the chart we can now deduce what we want to find out. So looking at the chart, we can see one, over 140 what records are from 0 point obviously 2 or 0.1 as the case may be. Alright. So the minimum value here is what? 0.1. So I can say as from 0.1 self, it's not even 0. I'm put 0.1. Okay. And I think that's the minimum. So starting from 0 almost. So let's say 0.1. Okay. To 10 million. That's where the most sales in the company happen. And then the biggest sales happen within 0 to what? To 5. The biggest sales in the company happen within 0 to 5. Then followed by 0 to somewhere around 7 or 8 before 10. Okay, so that's basically that. And I can do this chart. Okay, and that's plotting the first 10. If I increase this from 10 and make it 15, the chart becomes a bit too large. Okay, but ultimately, that is the idea. So, wherever you are, you let me know. Let me allow you to write. Are you done with the first graph or second graph? Which one? Which part? This first part or the second part?
This the second one.
The one that has this.
Yes. I don't know where.
Okay. Can I proceed? All right. So that's the insight. Then we can now start talking about the second type of analysis. So the univariate analysis is just where we explore one data type or rather one feature. Okay, we're only looking at one feature. We saw one feature up to now: scanning, selling price, present price. We're looking at one feature. Okay, so but when it comes to bivariant analysis, as the name suggests, it's not just one. We're looking at two, three, basically two. Okay, then we don't have multivariant analysis where we look at plenty features as from two upward, as from three upward. Okay. So the first thing I'm doing here is to get more access to more columns to see what I want more and more things that do I have access to. Then the second thing, so I'm now going to start looking at correlation analysis. Okay. One of the key things about bivariant analysis is this correlation, where we are trying to find the relationship between what? Two or more features or columns. Okay? Trying to find the relationship between two or more features or columns. Okay, and this relationship spans from -1 to +1. Okay? -1 all the way to what? +1. 0 in between. Okay? That is the range of values. So when a number has -1 or negative a negation, we assume that we have a negative correlation. When a number has negative symbol, we assume that we have a negative what? Correlation. Now, like I said, correlation is the relationship between what? Two or more um, features or variables, as the case may be. Now, the very first thing we're going to learn is what is negative, okay, correlation, and what is positive correlation. Okay, a negative correlation simply means that if a value, let me put it this way, if you're asked what is the correlation between tea and milk, then tea, milk, then tea and coffee. Okay? Then it can probably explain negative and positive. Okay? If the price of tea is going up and the price of milk is going up as well, they are all positive together. They are all moving in the same direction. Okay? And they have a value of 0.5 and above. You will say that this is a strong positive correlation. That is to say, whatever happens to the price of milk or to milk will affect positively tea. Meaning, if the price of milk is going up, the price of tea is also what? Going up. And that is for positive. Okay? Positive, they all move together, they all move in the same direction. Negative is doing the opposite. If tea is going up, definitely coffee is going down, because if either people are buying more of tea or buying more of what? Coffee. Okay? So that is a negative correlation. So one will impact the other one negatively. Okay? So if the price of tea goes up, and if people will purchase more of what? Coffee probably. Okay? Because of what? Can't afford tea again, they just go and buy coffee. Coffee is cheaper. And then there is what? High increase in what? Sales for coffee. Why there is what? Low increase in sales for tea. Vice versa. Okay? If the price of coffee goes up, people will be like, coffee is being, I have to buy sugar to use it, that kind of thing. So then you go back to the tea. Kind of relationship. So when there is an increase, okay, in one, and okay, it leads to an increase in another, okay, then we have a positive correlation. When there is an increase in one and it leads to a decrease in another one, we have a negative correlation. So that's the forum. Okay? So again, if it is one, then we have a perfect correlation. In fact, we assume that they are the same thing. Okay? That is what one is. So if it is one, we assume that they are the same thing. Okay? Then any other value in between is correlation distance, or how strong it correlates. Okay? Then if it is 0, we assume there is no linear correlation. So this assumes linearity, meaning that is, you can use a linear function, okay? You can explain them using a simple linear equation. The correlation between them. Then you can plot a line graph that's going this way, okay, which signifies this is positive, or going this way, which signifies negative correlation. Okay, that is that. Okay. So now I'm going to do a different type of plot for us to see what is here. Okay, before I do the plot, let me try and explain what you're looking at. Okay, let me plot them and explain. Okay. So what we have here is what we call a scatter plot. Now, one of the things I would like us to learn on our own, I'm trying to explain it, is to learn the kinds of plots we have. Okay, we've seen at least bar. Okay, we've seen hist. Okay, there is pi. Okay, and now we are seeing what? Scatter. Okay, so with this ones, I think there is more. Okay, apart from this, I think there's one or two more that should be here. Okay, that we should also know one or two things about. But these are the most plotted ones. When you are seeing here, they're the most plotted ones. Okay, so now what we are saying is we are plotting a scatter plot, right? Then we are using our y data to be what? The present price, and our x data to be what? Kilometers driven. Now C serves as a way of coloring. Okay? C serves as a way of coloring. It's kind of giving it color. Then C map is like choosing a color scale. How different or divergent the color should be. Okay, there's a language for the word like that. Okay, so that's basically what all this is saying. So we are plotting this
color scaling.
Yes, color scaling. This part. Okay? It's telling us how the color should be scaled. Then this is telling us what the color should be based on. Okay? So that's why we are seeing that from kilometers driven, and the color scale is basically on this aspect. If I change this, it will change the color type. It will no longer be this kind of colors. It will choose another color, basically. So that's the thing. Now, in our y-axis, we have what? Price, present price. Okay, and then in our x-axis, we have what? Kilometers driven. So that's basically, then the scatter plot is basically pointing out from here and expanding outward. So it's concentrated inward here, meaning that we have more of whatever we are dealing with, okay, over here. And then at times we tend to divide this into what we are looking at. But here I have only, well, this part, which is here, the concentration, and then few outliers. These guys are the different categories that are available. Okay, so a car that was probably sold at over 80,000 or 80, it has 80,000, right? Or 80,000. Then had a very small kilometer driven, whereas a car that was sold for almost zero has a very high kilometer driven. So this can be as a result of what? The scale of the price system, the present price. If the scaling is such that we have 2020, okay, and we now have 0 point something, it will affect this have this kind of impact. If 0.2 is referring millions and 20 is referring 200,000, something like that. Okay? So it can have that kind of impact. But having said that, so that is what this is all about. So now, if I'm to analyze this based on what we have here, okay, so we can also see that as the present price is increasing, the kilometers driven is what? Increasing. Okay, that's what this is showing. Like this. Okay, that's what we also saw. And the last thing for us to do is just to write down the insights from there. Okay. Again, this number here says 0.2. So that means it's a positive relation, but not strong enough. You can actually say that this has a strong correlation. It's a very weak one actually. Okay, has a weak correlation with each other.